I'm James Thomas, and I worked with Cochrane and Anna and Ella for a number of years now on machine learning technologies. And so I'm going to cover the second part of the Web Clinic, what artificial intelligence is, rather, the opportunities it brings, and challenges regarding its safe use. So moving on from Anna's definition of AI, one of the things that you can observe as technology hype increases up a hype curve there are the shifting definitions. So sometimes it's automation, sometimes it's developing computer systems to perform tasks that would usually require human intelligence. That's a fairly standard definition. And then more recent UNESCO one around imitating or even exceeding human cognitive capacities, including sensing, language interaction, reasoning and analysis, problem solving, and even creativity. So there's an awful lot of hype around AI. And then, of course, we've got generative AI or Gen AI, which are really machine learning systems. They're still statistical models of language, but they're trained on very, very large quantities of data. And the reason that they've been able to achieve what they've been able to achieve, a lot of this is because the sheer compute power that we're able to bring to bear now, the memory and the way that we can now parallelize tasks. So rather than worrying about sort of fitting everything on one computer, if you like, you can have thousands of them working all on the same task, building the same model. So generative AI can generate a range of different media, text, images, sound, all of those kinds of things, including some of the images like this one in the presentation that I've put together. And they seem really intelligent. I think that's one of the seductive things about them, that you almost think there's an intelligence behind driving some of this. And I think it's really important just to bear in mind that they're still statistical models, and the degree of actual intelligence there is questionable at the moment. So I thought we'd start with a little story on the development of recent history of language models. So if I had a poll device here, I might sort of ask how many of you are using Galactica, because Galactica was released by Meta. And it's trained on humanities scientific knowledge, as it says here, and you can use it to access and manipulate what we know about the universe. Sounds great. There's a paper which describes its technical development. Yan Yukun, who's a Nobel Prize-winning computer scientist, knows what he's talking about, says it's amazing work. And Galactica itself was used to help write its own technical paper, including recommending missing citations, topics to discuss in the introduction and related work, recommending further work, helping to write the abstract and conclusion. Really quite interesting stuff. So why aren't we all using Galactica? And I assume that if I'd done a poll, that there would have been nobody at the moment who's using Galactica, and probably very few of you have even heard of Galactica. After the excited launch of Galactica, it lasted 3 days online before it was taken offline. Very, very quickly, scientists tested it and found that it was little more than statistical nonsense at scale, according to Grady there. Someone from Max Planck, Michael Black, tested it in detail, was troubled. In all cases, it was wrong or biased, but sounded right and authoritative. He thought it was dangerous and reported some of his concerns. So it was incorrect regularly, hilariously bad at other times, and it also, as the bottom little image there from the conversation reported, was generating highly toxic content. And of course, this wasn't a surprise to anybody working in the field. This page, limitations, was published along with the language models, or the language model itself, rather, warning people that language models can hallucinate, which is an interesting word to describe what's happening there. There are no guarantees for truthful or reliable output. Never follow advice from a language model without verification. They're frequency biased. This is a really key point about trying to take information out of a language model. They're good for generating content where they've got an awful lot of data which basically says the same thing, well-cited concepts, but they do much less well for less cited concepts. So where there's much less training data, and they do very, very much less well. And they call this thing called hallucination is more likely. The language model itself cannot tell the difference between whether it's hallucinating and when it's actually got the facts right. So language models are confident but wrong often. So some of the text appears authentic and highly confident, but might be subtly wrong, or indeed very obviously wrong in important ways. So in that sense, it's kind of almost surprising that Galactica was able to help write a paper in the way that they were describing there, given its limitations. So we're all using ChatGPT, I'm sure, and of course that's different, isn't it? Of course, there's a lot of hype about ChatGPT. Some of the headlines I've put up here, and even people who are real leaders in their field, Eric Horvitz, Peter Lee, and the like, getting really excited about sparks of artificial general intelligence that they were seeing in GPT-4. Jan LeCun, who was obviously he's part of Meta, slightly less enthusiastic, and worked quite hard at the time to try and correct this perception that ChatGPT was new, innovative, and unique in terms of its technology. He was saying it's just not. In terms of its underpinning technology, it's no different from Galactica. So he's saying that the difference is about product development rather than research and development. And of course, this is a little bit salty about his experiences, no doubt, with Meta and what happened to Galactica, but actually genuinely has a point here. So what that brings us on to is asking, well, okay, so if the underpinning technologies are basically the same, what did OpenAI get right and where did Meta go wrong? And again, this is an AI generated image. The idea I did ask the image was to put OpenAI in front and smiling, but anyway, we got part of the image right anyhow. So where did OpenAI go right or get it right? So when you train a large language model, there are multiple steps that people often go through. So first of all, we train on a very, very large quantity of text. It's almost sort of unbelievably large amount of text that's put into these things. And what that training does is it trains a model to predict the next word given a prompt. So if, for example, if I put a little phrase like "there's no place like" into a base model, it might well predict the next word being home. There's no place like home, etc. What they don't train them to do in these base models is train them to chat or do things like that. The idea of these is they predict the next word. And Galactica is essentially a base model. It's quite a fancy base model, but it's a base model. OpenAI and Google with Bard and Gemini and other larger language models then do some more work. They do fine-tuning. When I've put relatively small quantities of data, we're still talking about a very, very large data set, probably of millions and millions of records, but nothing like as large as the huge data sets that are used to train the base model. And this fine-tuning trains the base model to do particular tasks, sometimes in a specific domain. And so it's at this point that the model, if you like, learns how to chat and answer questions. So this is a very, very important stage in the development of a language model. The next really critical part of the reason that OpenAI was more successful than Meta is this reinforcement learning from human feedback. There's quite a complicated technical implementation here, which involves rules-based reward modeling and all sorts of things that essentially train the model to give better answers and the type of answers that meet expectations of what a good response is. And it's here that all of the work done to remove toxic content is implemented. So at the beginning here, we may well have a lot of toxicity even in the training data because of the scale of the training data. It's actually quite hard to remove bias and toxicity at that stage. And what the companies try and do is they build a large model and then they train it not to, if you like, regurgitate or to output some of the material that it's learned. The challenge here, of course, is that the material has already been learned. And so it's really difficult, if not impossible, actually then to train out of the model the bias which it's learned originally. But they have had a lot of success with it, and that's why they didn't have to take it down in 3 days. So they've got a paper which is open. You can go and look at it, where they detail all of the work that they've done to reduce bias and toxicity from the outputs of their models. And you can see some of the statistics they produce, GPT-4 producing toxic generations only 0.73% of the time, which seems really small. GPT 3.5, which is the open one, 6.48, and this is on a specific training data or test data set for toxicity, which sounds relatively small, but obviously when you think that there's millions and millions of requests going in there, that's still quite a lot of potentially toxic content being produced. But they've managed to reduce it to a level where it's been it's received anyway quite a lot of recognition and obviously a lot of attention and a lot of use. And what they've also tried to do is increase accuracy. This is more difficult to measure, but they're claiming that their model is more accurate now and also less offensive in what it produces. So their work has paid off. It produces less objectionable content, and it seems to be more accurate some of the time. And it's obviously transformed our popular perception of AI and prompted lots of other companies to try and catch up, releasing language models of their own. And the results can indeed be very, very impressive. In our field, thinking about data extraction, for example, one of the language models, Claude 2, I experimented with this a little while ago, uploaded a randomized trial of smoking cessation intervention and simply asked, give me the PICO, essentially, of this trial. And the language model quite happily reads the PDF and gives me a nice summary of the PICO from that report. I asked it, state in tabular form the outcomes of the study. Not any about study here. This is a really interesting piece of work from the language model, if you like, because it nicely generates a table for me. But it also pulls information from both from the text of the document and a table in the document in order to produce what are accurate figures in this summary of key outcomes of the study. So really, really quite impressive. I also then asked what was the risk of bias as assessed by the Cochrane risk of bias tool. I didn't even write it out. But because there are so many examples of the Cochrane risk of bias tool online, it's able to regurgitate, recreate the risk of bias assessment, and really interestingly, being able to do it on the basis of this PDF. And did a really good job in this case of assessing risk of bias. In another use case, ourselves and Campbell collaboration, we had an experiment mapping the literature on AI and equity. We did a conventional search of 19 databases, using really quite a thorough search strategy. And then we used GPT-4, the OpenAI model, to screen the records and to map the records very, very broadly. Not cost-free, cost about £800 to use this because it took several days using the API continuously, and we evaluated it, and it was accurate. We shouldn't take these stats as being representative of any use case. This was relatively easy task for the language model. It was asked to put things into these broad buckets about what area of implementation, which discipline essentially it was, whether it was to do with criminal justice, disability, environment, education, health, etc. Really big broad buckets, and which domain of equity the paper in question was looking at. So a relatively easy task, but still really quite impressive. What was interesting about this was that at the end of the process, we had a map that we with 6,500 records in it, but actually, because the research team hadn't sat there and read all of the papers, we actually don't know what's in the map at the moment. It's one of those, we're almost sort of end users of a map that somebody else has produced. So this is really interesting and really useful, and it's because of this this concept that's been called zero-shot learning. And what's that? Well, it's quite a game changer. If we sort of cast our minds back to thinking about how the Cochrane RCT classifier was developed and evaluated, we worked with the Cochrane IRMG and information specialists to identify what an acceptable threshold for accuracy would be, which was 99% recall. And we built a model to begin with, a conventional machine learning model, using a couple of algorithms into an ensemble. And we had 280,000 records, very accurate records, which distinguish from records which described randomized and non-randomized studies. And the model was calibrated then at that point to achieve 99% recall on a second data set. So to begin with, we had 280,000 records from Cochrane crowds, nice large data sets, and then a data set which is used a lot for testing search strategies and search filters, the Hedges data set. We calibrated it to make sure that our model would achieve 99% recall on this data set. And then we had a third data set, Cochrane studies, Cochrane RCTs, included in Cochrane reviews to validate the calibrated model, to check that out of those 92,000, we were achieving at least 99% recall. So at that point, then we had a model which had been developed, tested, and validated, and it's now been deployed live for use in Cochrane reviews for a number of years. But that's a lot of data that we used there. With zero-shot learning, when we're thinking about using a language model for this, the big advantage and the advantage that we saw in that map, we didn't need to create 280,000 records to train a model and a calibration data set. What we needed to do was to write prompts in our normal language, check that the prompts worked on our data, and then we used it. Does it sound too good to be true? Well, I think we have to cast our minds back to the experiences of Meta and Galactica and the warnings that came from that, because fundamentally the underlying technologies are no different. So we were using a language model that can hallucinate. We can't guarantee that it's going to be a truthful or reliable output. Frequency-based is really good for generating and understanding content about stuff that it knows well, less good for less cited things. And it always sounds confident, but can be wrong. So we need to bear in mind that. And when I showed you those accuracy statistics on the map here, wherever they were, that was because we actually then evaluated the accuracy of what we were seeing. What we don't know at the moment is if we're thinking about using a language model for this type of activity, how accurate it can be and how generalizable the use of a model for those kinds of tasks might be. So when can we know that? And there's guidance and standards starting to emerge now. And this is really quite an interesting, it's quite a fun little flowchart here. But if we start at the top here, fundamentally, does it matter if the output is true? If it doesn't, then you're safe to use ChatGPT. That's fine. Obviously, for Cochrane reviews, it does matter quite a lot. And at that point, we have to think, do we have the expertise to verify the output is accurate? In a lot of cases, yes, we do have the expertise. We can look at the outputs and say to ourselves whether or not it's accurate. So hopefully, if the answer is yes, if the answer is no, then we just shouldn't use ChatGPT. And then are we able and willing to take full responsibility for the use of it? So there's two really quite important bars here. One is having the expertise and the willingness to do the checking and also taking responsibility for it. And then it says, okay, so it's possible to use ChatGPT, but make sure that you verify the output. So something that Ella's going to talk about is in terms of the Cochrane adoption of technologies is around developing guidance, and there's a lot of guidance around research integrity, and considering how some of those principles that underpin research integrity can be quite helpful in terms of thinking about how to use language models in research and in systematic reviews in particular. So I won't talk about all of them in detail. I'll just mention one or two as we go. So fundamentally, of course, the use of a systematic review must be clearly justified by the evidence. The Hoover's just come on. An AI tool has just decided to start, in other words, in the house. The use of the tool must be justified by good evidence. And here, rigorous and valid evaluation is absolutely key. So when we think about the developments of the pipeline to justify the use of the RCT classifier, we've got our 4 stages here. We've got the 3 data sets we made sure that we had a very robust and defensible pipeline there. When we're thinking about using language models, we need to be equally robust and defensible and accountable for what we're doing. When we're thinking about prompt development, in particular with a development data set, we need to test with a different data set. And we can't then assume that what we've developed here will necessarily work beyond the review context, for example, that we're working with. But what is absolutely critical is we must avoid contamination between development and testing. It seems very sensible and obvious, but there are lots of papers coming out which do not do this, and essentially bias the results of their evaluation by essentially developing prompts on some records and then reporting results of those records plus other records, and essentially marking their own homework. This is not a valid test of the accuracy of a model. So we must avoid doing that. And the problem is that it's very, very easy just to sort of think, okay, so I've put this prompt together and I test it on something else and think, oh yeah, if I only had just put that word like that way around, or I'd added another word in, then I get a different result. So I change that and tweak it, and suddenly actually we've created an invalid evaluation. So it's really important that we've got discipline there in the way that we do this, so that we avoid doing this. Are findings replicable? And there's been a lot of talk around just the fact that whilst in the RCT classifier world, it's a deterministic algorithm in that we get the same results when we put the same input in, versus these non-deterministic algorithms, which are the language models. There are ways of making sure that we reduce to almost zero the way in which it might give us different answers. But that, again, has to be part of the evaluation and part of the way in which we set up the tool for use. And what we do need to do is to start to think about how we build a cumulative evidence base. And there's a paper that's come out recently on studies within a review, or SWARs. And I think here, this initiative has got a really important role to play in helping us to undertake what are often small studies, but if we all undertake them in the same way, keeping the same methods, then we're actually then able to pool the findings from one study to another in terms of a systematic review. And then we will then have a cumulative evidence base from which we can then start to learn how we might actually be able to generalize the use of large language models in one review to another. As was mentioned earlier, these models are biased. There's no avoiding that. But whilst this reinforcement learning has removed obvious and objectionable output, the biases are deeply encoded in the model, and there's some interesting research being done to identify and to sort of surface some of these biases. So you can see on this paper in the Lancet, for example, GPT-4 did not appropriately model the demographic diversity of medical conditions, consistently producing clinical vignettes that stereotype demographic presentations. There are problems with using models in healthcare, and we've got to be really careful that when we're using a model in the context of a review, that we don't inadvertently reproduce those biases. So ultimately, of course, us as review authors are accountable for the selection and use of the tools. The tool itself can't be accountable for anything. We can't blame the tool for being what it is. We shouldn't take on trust marketing materials. We need to carry out our own evaluation, our own test. And it's important that we understand, not necessarily in huge technical detail, but at least up to a point, how the tool works, so we can gauge its risk in the reviews that we're working on.